Hello everybody and welcome to another Desk of Lady Ada. It's a Friday night and that means it's time to go to the clubs and do some MQTT hacking. No, we're staying home and doing some MQTT hacking. Maybe we'll go to the clubs later. I thought I would do something kind of different. I thought, I just released a tutorial on Adafruit.io, MQTT, and U, which is kind of an introduction to, what the protocol that I use Adafruit.io with, which is MQTT, and kind of go over it and then maybe wire up a really quick demo to show how easy it is to use MQTT. So you can pull up the tutorial. It's on learn.adafruit.com, and it's /MQTT/Adafruit-io-and-U. And here it is. And so I thought, let's kind of just go over it, and I'll kind of talk through it and then maybe explain what I was thinking about with this. So MQTT is a protocol. It's a higher level protocol that is designed to let low power, low complexity objects talk to a server. And usually when we talk to a server, we use, I'm using a web browser right now, and so you would connect up, your web browser and TCP port 80 and type in the URL, and you can use that to connect to servers. You can use protocols like FTP and Telnet or Gopher or whatever, UNet, whatever other protocols you want. Most people tend to use SSH or web. But the thing is, if you want to implement a web browser, it's actually a lot of overhead because it's meant to deal with videos and embedded things and all sorts of different connection types and permissions and passwords, and it gets very complicated. And it has to support any browser that wants to talk HTTP. There's so many different options and error codes. But let's say you have a small device an Arduino compatible. Microcontrollers like Arduino compatibles and such, tend to have about a couple hundred K of flash. Sometimes they only have 32K of flash. That's kilobytes, not gigabytes or megabytes, but kilobytes of flash, and can have as little as 2 kilobytes of RAM. And there's no way you're going to fit a web browser in there, and it's even tough to do even part of the HTTP or HTML specification. So what you might want to use is MQTT instead. And so MQTT, which stands for MQ Telemetry Transport, but it actually doesn't mean that anymore. I think it was originally developed for satellites. If you have a satellite that's sending data, and it's in space. I mean, it's in space. You can't connect your AVR dude programmer or your JTAG, JLang. It's in space. It's sending data, and it has to send very short bursts of information, and it can't have huge packets and a lot of overhead. It has to be super precise and send exactly the minimal amount, but with enough information so that the data is received properly. That's kind of where it came from, but it's really useful for devices that use Wi-Fi or especially cellular and especially Bluetooth Low Energy. So the second page I talk about why, and I have this lovely toaster. So you have this thing, and people always say connect your toaster to the internet. So I used a toaster, and this toaster wants to talk to the world. This toaster doesn't have to be a toaster. It can be your water meter. It can be your scale. It can be your interconnected cat feeder. It can be your greenhouse. I'm just using a toaster as a stand-in. So, what you used to be able to do, and kind of the easiest way to connect things would be plugging in Ethernet, right? That's an old protocol. You get some sort of Ethernet transceiver, now people use WizNet, but you could also use Cirrus. I once wrote for Cirrus Ethernet chips. They connect that to the internet, and then, you can send data to a server. You can actually open up a port and just push data through. But you might actually use other protocols. Ethernet requires wire. That's so lame. That's so 90s or 80s. Nowadays, you want to use Zigbee or Bluetooth or Bluetooth Low Energy, 802.15.4. You want to use cellular. You want something to be wireless. And so when you do wireless things, they also tend to be battery powered, or they usually have the ability to be battery powered. And also you're paying higher data rates. Like cellular, you're paying, much more per byte than Wi-Fi. Wi-Fi, it's like you get infinite data for $20 or whatever Comcast or Time Warner offers you. With cellular, you do pay by the megabyte. And so you have to think about it. You can't use all the data you want. You want to be, again, very specific and precise with your data. And so there are some people who use Internet of Things, and they just use, like I said, basically not a web browser, but they mimic a web browser in a sense. And they use HTTP, and they'll post or get. That's the two ways you post or get from a server using HTTP, and you can format your data in JSON, or you can even have HTML pages and forms and stuff. But there's a couple of issues with that, which is why I don't tend to use it. I mean, if you have like a Raspberry Pi or a BeagleBone and it's on Wi-Fi or Ethernet, then it's fine. But when you're getting to a smaller processor, first off, there's a lot of overhead because you have to have so many layers of protocol to have HTTP requests. Like you have to handle all sorts of errors. But most importantly, the thing that's really annoying about HTTP is it was designed for web browsers where you go to a page and you grab data and then you display it. You don't maintain an open connection. You can connect to your web server, you grab your image, you grab your page, you grab your data, and then you close the connection immediately. And that's exactly what web servers are great for. They're like, it's perfect for single serving. You get one thing and you close it. I mean, there's ways to hack around it, but for the most part, that's kind of how web servers are designed. And so what you would do if you were, like, if you had your ESP8266 is you'd connect to a server and you'd have to keep pinging it constantly, saying, is there data for me? Is this changed? Do you want me to turn on the toaster? Do you want me to change the temperature? And this polling, you have to do a full setup and tear down of your TCP connection as well as your HTTP connection. It's just, there's a lot of data going back and forth to do the setup, and it takes a lot of time. And also a lot of power. So again, if you're battery powered, this is kind of a bad scene. So what's nice about MQTT is it's really, really, really lightweight. The packets are very small. I mean, you can have data packets when you transmit data, and it's like 20 bytes. It's designed very easy to parse and use with an 8-bit microcontroller. And you keep the connection open all the time. This is a little tougher on the server because the server, the nice thing about web servers is that they as soon as the connection's open, they can close it after they push the data out, and they can optimize for that. With MQTT, the connection stays open all the time. Now you might not be transferring a lot of data, but the connection is still open all the time. So on the server side, it's a little more annoying because you have to have the server that's okay with, this is going to be a connection, and it could be open for weeks. You could have the socket connection or TCP connection open for a very, very long time. So that's kind of why it's not, there might be times when you don't want to do that, where if you know that you're going to be pushing data rarely, you're never going to be pulling data down from the server, and you don't want to maintain a connection, like let's say for cellular, you want to be able to set up the GPRS connection, send the packets of data, and then tear it down and go into a deep sleep mode, or maybe with Wi-Fi as well. That's when you would want to maybe look at using HTTP REST. You could still do it with MQTT, but you'd have to do that setup and tear down. Another interesting thing about MQTT is it does not depend on the underlying layer. You can do MQTT over Bluetooth. You can do MQTT over XB or Zigbee or Wi-Fi or Ethernet or TCP. I mean, we're going to be using it with TCP, but you don't have to use a TCP IP connection. It doesn't have to be on the internet. You could have MQTT between two Bluetooth devices. You could have your XB network with a mesh network, and it could be MQTT. It doesn't, all MQTT says is, when I send this packet, send me back this packet type stuff. It doesn't, and the packet is just like bytes of data. Hey, you could do MQTT over MIDI. Like, you'd be a little nuts, but you could do it. I don't know, maybe somebody will do it. So if you really want to use HTTP in a REST interface, we do have an interface for that, but this tutorial is about MQTT. So the next thing that is interesting about what Adafruit, that kind of explains what Adafruit IO does is you're going to have this main server, and every MQTT device is connected to it. So if you have an internet-connected home, your light bulbs will be connected to it. Your light bulbs can be connected to it. Your scale, your internet cat feeder, your toaster, your fridge, all these sensors. If you have a greenhouse, every plant or tree, all these sensors would be connected to one broker. And the broker is basically, brokers, when you think of like financial brokers, are the people who trade money and equities and securities. In MQTT speak, the broker is that main server that takes the data alerts and stores them and then sends them out. Brokers can store the data in a log, but they don't have to. It's not a requirement of the broker, like some do and some don't. Info.io does. It keeps the log so you can look at your history, but you don't have to do that. There's like nothing in the requirement of the broker that says, that I've seen, that says it has to log it. So instead, like you would have the server, and then like let's say your car is on a cellular connection and it has GPS, and then when it gets close to your home, it sends a message to the MQTT broker and says, hey, I'm a couple miles away from home. Then the MQTT broker actually doesn't have any thoughts, really. It doesn't think about like what does that mean. All it does is say, okay, everybody, like I just got this message. Do something with it if you want. If it's useful for you to know that the car is 5 miles away, great. I don't really care. I'm just the broker. I'm just passing along the message. And then your toaster gets that message. The car is 5 miles away, and it's like, okay, I have a program set up that when my owner is 5 miles away, I'm going to start toasting her a Hot Pocket. And so it starts toasting. And once it starts toasting, it sends a message back to the broker and saying, hey, Hot Pocket is on its way. Will be done in 2 minutes or whatever. Maybe it'll also broadcast the temperature or like the ETA or what Hot Pocket flavor it is, and then the MQTT broker will send that message again to anybody who subscribes. All it's doing is ferrying the messages back and forth. And so you might be wondering, like, why even have this broker? Why not just have the car talk directly to the toaster? Well, the reason is that if you have only 2 items, you don't need a broker. You just have them pass messages back and forth. But if you have more than 2, you're getting that n-squared complexity. Now the car has to also, has to know about the toaster, and has to know about the phone, and maybe has to know about your cat feeder. When you have the broker, each client in the MQTT mesh that you've got for your personal network doesn't really need to know about any of the other ones. It can just send and receive messages as necessary and react on them. So it makes it, you do need to have the central server, but it makes it a lot easier to add and remove devices because you don't have to, if you added a refrigerator, you wouldn't have to tell every single device, hey, by the way, you now have to send all your messages to this refrigerator as well. They only have to send messages to your broker. Okay, so that's a pretty good introduction. And maybe if there's questions.
Yeah, here it is.
Okay.
Is MQTT a full message queue system like Kafka, or is it more lightweight?
I've never used Kafka. Sounds Kafkaesque. It's you can check out the MQTT org. It's really, really lightweight. Like pretty much. I'll go through basically an example, but basically you can subscribe to topics, you can publish topics, and then you can add quality of service for acknowledgements. There's no. I don't recall ever seeing anything in the MQTT spec where you queue the message. You have a queuing system where you say these get them first or these messages go in order. MQTT is kind of designed for like, I've never seen or heard of a broker with like 10,000 clients, but the idea I think is that when you get a new message, you just blast them out to everybody. So it's really simple. And that makes it really easy to implement on an Arduino compatible, which is why we like it. Apparently CoApp is even simpler, but I haven't used it as much. But I really like MQTT. It's like I've gotten it working really well on all sorts of transports.
One more question?
Yeah, sure.
All right, next, is it FIFO message queue or publish subscribe?
This is a publish subscribe system. So when, we'll actually talk about it in detail, but the server gets publications, and it gets like this 5 miles from home is a publication, And then I started toasting. That's also a publication. And then the car is 5 miles away as a subscription. So we'll talk about that, but basically the toaster subscribes to messages from the car. It says, give me all the car messages. So that reduces it from a total insane blast of like every single device getting the message. You have to actually ask for that message. Or you have to ask for those messages when you connect.
Okay. Next up, do you have any plans for MQTT or maybe a WebSocket library for the Arduino ESP8266?
Wow, wouldn't it be great if I went over that? I will.
Okay.
So stay tuned.
All right.
I'm going to go over that.
All right, that's it for now.
Okay, great. So I don't know that much about like queuing theory, by the way. So like, pardon me if I messed up my queuing theory words. I've always assumed it was sort of like how you manage a real-time operating system, but maybe they're talking about something else. Okay, so you want to get started on Adafruit.io. Okay, no problem. First up, basically Adafruit.io acts as an MQTT broker. So you're like, where do I get a broker? Like, do I go to the store? Do I make my own? You can. You can install an MQTT broker on any computer. I know there's tons of Linux brokers. There's probably also ones that you can run on Mac because it's Linux-like. And Windows, I'm sure there's one as well. You can run on your home computer and just play around with it. But Adafruit.io, the whole point of it is that you don't have to run your own broker. You can use our broker. We have like one really big server, and you make an account. It's free, and then you can use our broker, and that way you can connect to it from devices around the world. You can have like one device measuring the temperature in Japan, talking to an LED that's in Saskatchewan. Like it's worldwide because it's on the internet. Okay. So we're going to be using MQTT 3.11, which is the latest version. Confusingly, it's sometimes referred to as version 4, but it's 3.11. We're going to be using the internet. So you can use Wi-Fi, Ethernet, cellular. If you're using something like Bluetooth Low Energy or Bluetooth or Zigbee, you will need a gateway. If you're using Bluetooth Low Energy, the Adafruit iOS Bluefruit Connect app has an MQTT gateway that takes BLE and uses your phone to route that to cellular or Wi-Fi through your phone. But basically, you have to be able to get to the internet. Like you have to reach Adafruit.io. We're going to do the demo with an Arduino compatible. We're going to be using the Feather Huzzah, which is ESP8266. It's basically a Wi-Fi chip. It has a battery power if you want and can charge the battery, but we're going to use it just connected up to USB. Just know that I could have this portable if I wanted to. It's just faster to develop. You know, plug into USB, do all your development, and then later on, maybe I'll grab a battery and we can make it portable. So it has Wi-Fi, and you can program it through the Arduino IDE. Okay, you also have to have your Adafruit.io account. So you'll have to do that. So do that. And then you can go to your account, and you'll have feeds and dashboards. And we have tutorials about all the things about that. You'll need an Adafruit key. So your feeds, I have a whole bunch of feeds because I've done so many tutorials. You can create lots of feeds. You can also get your key. I always forget where to get your key from. Sorry, it's in settings. Click on view Adafruit.io keys and you'll get your key. Don't use my key, use your key. And your key basically means that only you can write to your feeds because you don't want somebody writing to your feeds without permission. You'll need your username and you'll need your key, and here's how to get it. And then you'll need to make 2 feeds. One is the photocell feed, and one is the on-off feed. So we're going to have one feed that's data coming from the device, the ESP8266 to the server. That's photocell, just like basically just means a sensor. And on-off, that's a way to send data from Adafruit.io to the device. So what's neat about Adafruit.io and what's great about MQTT is MQTT does push and pull. You can send and subscribe. You can have data coming one way and then the other. Like I said, with REST, it's a little tougher because you have to pull. But with MQTT, it's quite easy. Okay, so you'll also need a dashboard. We're going to use, I already have this dashboard. It's going to be Huzzah. And I have a couple other feeds here. You can just ignore them, but I'm going to be basically using the light level feed which is the photocell feed and the on-off feed. And then I have some other feeds, but you can you don't have to use those. This just shows you like how to make the dashboard. You basically drag and drop. You can edit and drag and drop the feeds around, so you can make this larger, and then you can make this larger. So you make your own custom dashboard. Maybe I'll move this down here. Move this down here. Okay. So you get your dashboard, or lovely. You get your photocell on-off feed. Okay, so great. So dashboard is ready. You don't actually need to use the dashboard. It just makes it a lot easier to debug what's going on because you can see it visually. You basically need to download adafruit._MQTT and install it. It's a library, so if you've done Arduino stuff, it's pretty normal. Hold on, let me close some older windows. And then you will open up the Adafruit MQTT and then the ESP8266 example. And this example is basically your first step in playing with MQTT. So it uses the library, and then you'll need to put in your SSID. So let's do that. And your SSID password. You'll need your Adafruit IO username. And then you'll need your key. So put your key in. And then it's going to use Wi-Fi to connect to your SSID. And then once it's connected, it will connect to, it'll connect to io.adafruit.com. This is the MQTT server using port 1883. This is the standard port for MQTT. And then, so that's kind of your initial setup. So let's go back to the tutorial. You can also use the CC3000. We have example code for FONA, CC3000, but I like using the ESP8266. So yeah, set up your credentials. This is just some basic stuff, like make sure that you can connect to the internet. Okay, so let's just upload this to my ESP8266. So upload it. Give it a moment. It's got to do a lot of programming. Compile every single CPP. Okay, now it's going to upload. And we'll just see what happens and look at the board without looking at the code yet. So right in the flash, let's wait till it's done. Okay, so now that it's done, I'm just going to hold down reset while we open up the serial monitor. Oh, wait, it has to be the right baud rate. Yeah. Hold on. Let's reset. Okay. So it starts by connecting to your SSID. It connects to Wi-Fi, has an IP address. And, oh, you know what? I have MQTT debug on. Hold on. Let me turn that off because that's kind of exciting. Hold on. I forgot I was debugging earlier. So turn off debug. Debug is handy, but not when it is so noisy. Okay, upload again. And hopefully this will work. Ooh, connection failed. Did I get something wrong? Let me check my that'd be sad if it happened to be down. But then we'll just continue another time. Got everything. Connecting, uploading. Let's try again. Although, that'd be sad if it happened to be down. Retrying. Oh. Hey, can you, do you mind going to the overhead?
Yeah, I'm on the right now.
Oh.
Right there.
No, I mean as the main screen. Okay, so 1 second, because I don't want to. All right, there's some elevator music. While I just see if the server is being iffy. It's odd because I can get to it. I think the server's down. Oh well, we can continue this tomorrow.
Okay. Let's answer one question.
I'll answer a question. I think I just had the worst possible luck with. Todd will look into it. I'll answer a question. He can see if he has to kick it.
If I run an MQTT broker at my house, can I set up the forward messages to Adafruit.io?
Oh, that's a good question. Yes, but you would have to basically rewrite the requests so that you would get the packets of data, and you can't just send the raw data directly. You would have to kind of like massage them into like the right, like you'd have to connect to Adafruit.io with the key or using REST and push the data. I mean, you'd probably push the data using HTTP instead because you already have a server, so it's like a lot easier to set up like Python or Node or something to do that forwarding for you. It's possible. I haven't heard of someone doing it, but it's not like there's some synchronization that you could automate. There's no like MQTT synchronized command. You have to actually send each piece of data.
Okay, and someone says low residue hotness for long range requires gateway with internet handoff can push up to 12 miles.
That is correct. And we did the RFM 69.
Everything seems to be up for.
Really?
Yeah.
Oh man, what on earth?
I'll go to the.
Hold on. How can that be? All right, let me try connecting. It's not. I'll keep clicking this page. This is funny. I have the key and everything. I don't know. He says it's up, but I'm timing out. That's really weird.
Do you have any like utils that you can do just to like make sure?
Yeah, there's an MQTT effects. Let me try that. Because it's very odd because, of course, oh no. Ugh, it doesn't work. Yeah, I know. Java, great. Nope, he says it's up. I wonder if there's something in our network.
Why don't you try?
Let me see, because I want to connect to our main network. Server's up. I am at a loss.
All right.
Well, live demos. That's how they go.
Yeah. Well, you have.
Wait, now it's working.
Yeah. See, I knew I had to. That's all I had to tell you.
Okay. I don't know what happened.
Do you want to go back to your screen?
Yes, sure. Because I pinged it. It was about to be like, oh.
This is why I'm here.
Good job.
Yeah.
You're great with networks. All right, I don't know what I probably typed something wrong or had whatever. Anyways, whatever. So once you kick the work. Oh, thanks, Todd. He also kicked the server. Okay, so once you connect to MQTT, we're gonna basically we have the ESP8266 printing out this little message saying sending photocell value 0, 1, 2, 3, 4, 5, 6, 7. So I'm just incrementing each value. I'm not actually sending real sensor data because there's no sensors connected. So I'm just sending a counter. So let's go to adafruit.io and let's go to the dashboard. And this is that dashboard that we were editing earlier, so you can see that the number is going up. So every time this sends a message, 15, 15. 16, 16. It's like 5 seconds in between. And then if you go to the overhead, do you mind clicking to the overhead? Oh, you know what? This code doesn't have the, hold on, I don't think I added the, oh yeah, hold on. When I click this button, sorry, not the overhead, I meant the main screen. Sorry, I completely got that wrong. Sorry, when I click this button, it says got on, and then when I click it off, it says got off. So it's getting the messages, and you can see how fast they are. From between me clicking this button, it's like less than a tenth of a second for it to receive that message. And this is going through Wi-Fi and through the internet. So it's not a direct connection, it's going through a broker. The broker is really, really fast at getting the messages and sending them back out. So notice I can receive messages, so I'm sending this on-off switch to the ESP8266, and at the same time, I am able to get these messages sent from the ESP8266 to the broker. So yeah, this is that push-pull. Okay, so that's the publication test, and yeah, you can see that the data is clicking up. Oh, and here's another fun thing, which I always really like. So at the top, you can see these little blue dots, this little ants, it looks like, kind of chugging along. So that's packets being sent back and forth. So that kind of helps you know that there's data coming in to your in and out of your feeds. Okay, so then you can also go to your feeds. So the dashboard just displays what is in the feed. So if you go to the photocell feed, you can see the data that's being updated. So the value has been incrementing, 5 seconds ago, 10 seconds ago. So every 5 seconds, we get an incrementing number. So it goes back, and you can go back to 5,658 pages because I use this feed a lot to do tests for how long something can transmit for. And then you can refresh it and get the most recent. Likewise, if you go to the on-off feed, you can see on-off that you've done that way, and you can download your data. And like, let's say I wanted to create data, so I can manually send in the message on, and it will get sent. I can also send, of course, a custom message. And I'll get that custom message. So you can use the feed basically as just a way of sending data back and forth. Okay, so you also did the subscription test on off, and you'll get those messages as well. So this is basically like, okay, you just get to play with it. You get to see how fast it is, how it reacts. So let's actually look at the code that we uploaded. So, oh, wrong code. This code. So starting from the beginning, you've got, so you got the introductory with some links and stuff, and then you have to include the ESP8266 Wi-Fi, you have to include the Adafruit MQTT header and the MQTT client header, because we're acting as a client. Of course, your network stats, the Adafruit IO server port username and key. And then this part you don't have to change. It's just sort of your global state. You have the client that will be used to send and receive data. These are just consts, the program memory strings that are used to store these defines up here. And then here's where we actually make the MQTT connection object. It uses the Wi-Fi client. It connects to the server with the server port using our username and our password. And then that's the client. So MQTT, this is your client connection. And then you can have publications and subscriptions. So publication, again, is data being pushed from the ESP8266 to the server, and a subscription is data we're receiving from the server. So publish is you're tossing out, and subscribe is you're bringing in. We have the name of the publish object is going to be photocell, and the feed is your username and then /feed/photocell. Everybody, this is to keep every feed unique. You put your username at the beginning. At some point, we might make it so you can subscribe to other people's feeds. I don't believe that's available yet, but we will. Once we're sure of it, you'll be able to. For example, Phil has a feed for his internet cat feeder. I can subscribe to it and get updates from when the cat is eating from this internet cat feeder, stuff like that.
Someone has a public feed right now that shows if we're live on Twitch or not.
See, we have to get that on-air sign going. The internet connected on-air sign. Your publish object will take the MQTT connection and you give it the feed. Likewise, you can subscribe. So this is the on-off feed. And you have an object for your subscribe object, and then you also give it the MQTT client, and then the feed name. So that's pretty much it. It hasn't actually done anything yet. This is just your holder for the subscription and publish object. Then you have your setup. So you print out something, you connect to the serial. Sorry, you open up your serial port. You connect to Wi-Fi, and then you wait to be connected. Once you're connected, but before you connect to MQTT, you actually tell MQTT you want to subscribe. So the reason you do that is when you do the MQTT connection, you want to subscribe immediately. So by having this subscribe call here, you make sure that when you connect later on down here in the loop, it already knows it wants to subscribe, because every time it connects, it's going to say, hey, I want to subscribe to this list. It's very common. You connect and then tell the server, I'm subscribing to these topics. And then you have your main loop. So that's it. That's all you have to do to set up. And then the main loop, there's a connection helper. And this connection helper is, it's a function down here. All it does is check if you're connected to the server. And if not, it reconnects the MQTT. It retries a couple times, and it times out. And if it times out too much, it actually halts the ESP8266, which causes a watchdog reset, which means you'll start over from the very beginning. So that's kind of a safety feature. So if you are unable to connect to this server at all, it could be your Wi-Fi connection is borked, just start from the beginning. So you can change that around, but watchdog timers are handy if you want to just start completely clean. Okay, so in your loop, you basically want to spend most of your time waiting for subscriptions. So if you have a Linux computer with threads, you have protected memory, then what you can do is have a thread that's listening for packets and will call you when you get a packet. However, when you're dealing with something like an ESP8266 or an Arduino, you don't have... Adding a real-time operating system is a little bit more complexity than most people want. So instead what we do is we just wait for data to come in. We're not polling the server, we're just waiting for the Wi-Fi chip or the Ethernet chip or whatever to say, hey, data's ready. Again, if you want to use interrupts for this, that's totally awesome. I want to make this example very simple. You wait 5,000 milliseconds for a subscription, and if you get a subscription, this will return a pointer to which we're storing it in a pointer here called subscription. If you do read some subscribed data, it'll come in, and then you can compare it to which subscribe object you have. So if you have multiple ones, you'll just have multiple if the subscription is equal to the on-off button or internet cat feeder feed or whatever. You just have multiple ones, and you can just pick and choose how you want to react. In this case, all I do is just print out the value. So you do that for 5,000 milliseconds. You pretty much waste all your time in that part, just waiting. And then after about 5 seconds, whether or not you've got a subscription, you'll time out. It'll not return a subscription object, it timed out, and then you will send your photo cell value. So in this case, it's just publishing X. It prints out the X, and then it just calls publish. And this is all you just publish, and you send the data or the string, and either it says failed if it somehow failed, or you say OK. And then we also have this commented out section called ping. So when you have your MQTT connection, there's this idea called the keep alive. Basically, how the server doesn't want to keep the socket open if you've disconnected. It's like it wants to close the socket as soon as possible. That's what servers like to do. Less sockets open, less memory, easier for the server. So it wants you to send data every 5 minutes. And if you don't send data every 5 minutes, it'll assume that you're gone. Because if you're gone, you're not going to say I'm gone, like you've already left. So a ping is what you would use to tell the server, hey, maybe I don't have anything to publish right now because I'm only subscribing to data, or I don't have any publication data ready, but I'm still alive. So it's your keep alive. If you're publishing once every 5 minutes, you don't need to use the ping. So you just leave it out. It's not required because your publication is your way of saying I'm alive, I'm alive. And that's it. And that's the entirety of the program. That's all you need to use MQTT. Now you're sending and receiving data. So this goes through it, and you can talk about, this is that example of a publication and subscription. You can have multiple things you're publishing and multiple subscriptions. In theory, you can have an infinite number. You might run out of memory on your Arduino compatible or your ESP8266, but there's no limit to how many feeds you can publish or how many feeds you can subscribe to. You'll have to just juggle them. Okay, and then that basically what I went through. You wait for subscription. You can time out, publication, and this is about the MQTT keep alive. If you want to change the keep alive number, it's in adafruit_mqtt.h. Look for MQTT con keep alive. 300 seconds is a pretty good start. That's 5 minutes. You can make that as little or as much as you like. The smaller the number, the more often you're going to send data to keep it alive. Okay, so now let's make another subscription. So we'll have 2 subscriptions. So let's go to our dashboard. Let's go to Huzzah. And let's add a slider. And I already created this feed, but it's called slider. And let's make the value max 1,000. Create the block. And then I think I have to refresh to see it. Yeah. And then let's put this here, and then okay, and then my on-off button. Do some cleanup here. Hopefully it'll be okay with all this moving around. Okay, done. Okay, so now we have a light level. So this is the publication, and you can see it's still incrementing. Your on-off, which is a subscription, and we're going to add a new subscription called slider. So let's do that. Let's go to our ESP program, and we're going to create a new feed called slider feed. The feed is called slider. And this is also called slider. So new feed called adafruit2/feed/slider. Subscribe to the slider. Don't forget to update all the things. Okay. Let's wait for it to save. And then down here, you want to also subscribe to the slider. And then you can check here if it's the slider feed you got. And you can say, just print out the data you get from it. So let's try uploading that. And you just do that for as many subscriptions as you want. Again, it's no big deal. No biggie.
Say hi to Justin. He's watching.
Oh, great. Thanks for having A4.io up.
Yeah.
Yeah, I thought I'd try. Maybe I'll try to add this. We'll see how that goes. That would be fun. Live coding.
I think this is the only Internet of Things live video broadcast consistently right now. You'd think it's Internet of Things, there'd be all sorts of live video broadcasts all the time, but there's not.
Who knows? Oh man, now I got the connection. Oh, you know what it is? I think I know what it is. It is, I can only have a unique connection. No, connect, okay. I think you have to time out. We'll talk about that later because it thinks I was still connected. Okay, so photoval, okay, so you see this number is incrementing, so that's good. It's working. And then, I'm gonna kind of tuck this over here. I can move the slider, and now to keep your data plan from going crazy, it only sends the data when you release. So you can see the slider is moving, and that number is popping out. So 0 to 1,000. Works great. So, yay. So next step, let's actually have it do something. We'll try this out, see if it works. I'm going to add a 7-segment LED backpack to print out what that slider is showing. And so, you could theoretically have this number transmitted across the internet. So let's wire that up. So you get your 7-segment backpack, and then and for those who are watching while I'm wiring this up, tell Justin what a great job he did making Adafruit.io. Him and Tyler and Todd. They've been working on it for how long, Phil? A year and a half? How long?
I don't keep track of time like this.
There was before
there was
internet.
before IO, now there's before Adafruit.io, now there's Adafruit.io.
Okay, so hold on.
We are in the current time of Adafruit.io.
The only thing is I haven't actually tested the LED backpack with this, but if not, I'll see. So this is the LED backpack. I've got power, data, clock. Just want to make sure I got the data and clock right. Okay, so let's try. I'm going to try the example for the LED backpack that does a 7-segment. 7-seg. I'm just going to try testing out just the, I disconnected, I'm erasing the ESP8266 MQTT sketch, and I'm going to just try the 7-segment sketch because I actually don't know if it works with this library. It should, but I haven't actually tried it. Okay. Uploading. Okay, looks good. So can you go to the overhead? So I just got this working where it's now like, it's just displaying numbers. So now I'm going to merge these two sketches together. So at the top of my code, I will include LED backpack and wire.h. And then I'm going to make the new matrix. And then you do matrix begin and setup. begin here. Actually, I'm going to do a little fun thing. I'll have it print out the IP address slowly. So once it's connected, let's have it print. I don't know the form of the. Actually, I don't know the form of the IP address. I'll actually have it. I'll print beta F so I know that it's working. Okay, and then in the loop where I get that slider data, and this is the interesting thing. So when you get data from MQTT, it comes, well, it depends on how the MQTT server is set up, but basically the way our client is set up, it's actually kind of the way the client and the server is set up. When you pull the slider back and forth, that's stored as a string, or at least when the client gets the data, it comes in as a string. So when I'm printing this out, it's not a number like 1000. It's actually 1000 is like a quoted string. So what we have to do is convert that to our number, which is going to be a uint16, by using A2I, which is ASCII to integer, and then base 10. And then I think this is the right way to do it. Find out. And then we can just print that out, decimal. Too many arguments. Oh, maybe I don't have to put in the base 10. Maybe that's I2A. All right, let's find out. But yeah, you're passing in that last read value, that the value you get from the subscription, as a character string. So just watch out for that. Like if you actually try to use that as a number, you would be very confused because you'd be using the ASCII value rather than the integer value. I can see why people like loosely typed languages, but C is not one of them. Okay, it's done uploading. Okay, so I think it's going to connect. Okay, I waited long enough. And so it's sending data, and then if you go to the overhead, let's see if this works. When I move the slider around, I get different numbers, so I can move the slider. Do you want to maybe try to split screen it, or I don't know if that's possible, so you can see the slider and the. Can we hide one of me? Okay, yeah. So I'll just shade this, and then yeah, as I move it, and you can see how fast it is. When I let go, it's pretty much instantaneous. And even though they're both connected to the same network, we're both connected to the Adafruit network, it's not going through the Adafruit, it's going from Adafruit to Adafruit.io back. So it's a full round trip internet connection. And but it's like nearly instantaneous. So this is one of the really nice things about MQTT, is how fast it is. Just like, you know, I could be streaming real time if I wanted to, and it would be very, very fast for the round trip. Although I don't know if we measured the round trip, but I definitely would say it's less than 100 milliseconds. So I think that's a good demo to showing some wiring up. And we have, I'll just go over the one last section about, yeah, and this just talks about having multiple feeds. There's two more things that we have in Adafruit _ MQTT library. There's quality of service, and there's wills. So quality of service, also known as QoS, which I guess you'd say QoS, I don't know. The quality of service is a way for you to manage how to know for sure whether the MQTT broker really got your message. Because let's say, again, MQTT doesn't know it's running over TCP/IP in this case. MQTT is a agnostic protocol that is above, you know, Zigbee or XB or cellular or TCP. It doesn't know. And let's say you have a satellite connected to a base station, and they're using MQTT radio. You're using radio to communicate messages. The satellite can just like send messages into literally space, or vice versa. The base station can send messages to the satellite through space, and it doesn't. If you just sent the message, like you don't know that the satellite got it. Like there's no way to know. It's in space. Like it's not like with TCP/IP where you have like some underlying protocols that tell you like the packets were received. So MQTT has the ability to have a higher quality of service where you get a response back. So when you send the publication, you will actually get an acknowledgement packet back as well. And when you do that, it basically just lets you know for sure that the broker received your message. I mean, it is possible for you to send a publication message and the broker software's hang. It gets the data is received into the socket, but it's not actually saved to disk. So this way you would know that instead of something being crashed, it actually received the message, processed it, did everything it did, and then it will acknowledge that message. And to do that, you just add, when you make your publish object, you add MQTT _ QoS _ 1. And that basically lets you, when you publish, it'll return true only if it received that publication acknowledgement. There's also quality of service 2, which is even higher quality of service, and this lets you know that it was only received once. This might be useful if you have something like, okay, you're sending data to your satellite saying rotate 90 degrees. Well, you don't want it to rotate 90 degrees twice, so you want to make sure it only received that message once. But we don't implement that in the MQTT library. It's supported by the broker probably, but we don't have the library code for it because you have to start tracking like packet IDs. And so I'm like, well, we might add it later, but for launch we haven't added it. And then the second thing, which is kind of neat, is the last will and testament. And it's kind of just like a human last will and testament. When you die, you would have a document that says, I want to give my PlayStation 4 to my cousin, and my money goes to charity. It's your last wishes when you're no longer able to actually act on them. Likewise, for MQTT, there is a last will and testament where you can tell the broker, when I disconnect, write this value to a feed. And this is really useful when you want to have some indicator so that you know whether your client's on or off, or it's connected or disconnected. Because again, MQTT doesn't really know, it doesn't keep track of whether they're connected. It's just like, just send me data, and then when you time out, I'm going to assume you're gone, but I don't really know. It's kind of a nonchalant about your connection status. It just kind of looks for packets. So by having a will, you can force this broker to perform one last publication for you. So to do that, actually already have an example that's written for this.
Tyler's here too. Everybody.
It's a party.
Everybody is watching live devices connecting live.
Okay.
Live.
So I already. Let's pretend like I wrote the code. I'm getting a little tired, so I'm not going to write the whole code, but I will, however, disconnect my ESP so I time out. So in this case, you still have a feed, and it can be it can be a feed that you also publish to or subscribe to. But in this case, I'm going to use the on-off feed, and it's a special. It's a publication feed, and in this case, I'm doing quality of service 1 because I just felt like let's just do both things, and then when you before you connect, you tell MQTT, I want to set up this will. And the will is, when I disconnect, write the value off to will feed. So that on-off button will turn off when I've disconnected. Now you're wondering, like, how does the broker know when you've disconnected? How does it know when to do the will? Like, if it's a human, you wait, you have a mortician show up and they say, like, I declare this person dead. How does the MQTT broker know that? It's that same keep alive that you heard about earlier. When the keep alive times out and doesn't receive a publication or a ping, it's like, the client must be dead. I will enact this will. And I don't want to wait 5 minutes, so I'm going to set it to 30 seconds. So let's try uploading this.
George Graves is here. This is the, like, everybody.
It's everybody.
Everyone for Adafruit must have like a Adafruit IO.
Well, you know, I said it. It's like it's time to go to the club and do some MQTT. Well, this is the club. Oh wait, shoot! I think it didn't work. I got to re-upload. Hold on. It's going to time out. I hit reset at the exact wrong time. Try again. Okay. Yeah, it's a party. I didn't actually try this with 30 seconds, but we will see. Oh, and then, sorry, there's one more thing I forgot to say. When you connect to MQTT, the first thing it does is publish on. So when you connect, make sure you publish what you know, the non-will value on, and then when it disconnects, that's when you know you want it to be set to off. So let's go to the main screen, because I'm not going to be using the... Okay, so I just connected, and this is switched to on. So, you know, it's just setting that data as normal. And now what I'm going to do is I'm going to disconnect the ESP. I just pressed the reset button, so it's no longer setting photo cell values. And this should update. And hopefully, I hope it works. It might take a while. Actually, I don't know if the there's a will timeout that's even longer. Come on. I'll wait all day. Oh, it's definitely more than it's gonna take more than 30 seconds. There might actually be a hard-coded value at the broker that makes it wait longer. But that's cool. Oh, there it goes. So then it automatically turned off. It's a little bit more than 30 seconds, like a minute or so. Maybe it just seemed like forever. And then you can see at top, I had sent 3 data points, and then there was this delay, and then it detected that the client went off. There's no more data sent. It timed out, it disconnected, and it set this to off. So that's a way for you to, and then I can unclick the reset button, and then it turns back on. It's like, hey, I'm online. So you can use this basically as a way of indicating online or offline status for your device. You just set the timeout for whatever makes the most sense. Again, 5 minutes is more logical, but you can do it as short as you want, as long as you don't accidentally kick off the will, and then just make sure every time you connect, you tell it, hey, I'm on, and here's my will for setting the feed to off when I disconnect. And that's it. So that's all my demos.
Okay.
So I can take questions if there's other questions.
No, you go through most of them. Someone wants to know, is it Adafruit IO an MQTT broker?
It is. It is an MQTT broker with a lot of other stuff, because it has logging, and it has these dashboards, and it has REST as well. But one of the interfaces into Adafruit IO is MQTT.
Okay. Anyone know if I can use the Arduino to create to program the Feather Huzzah, or a third-party board's not yet supported?
I have absolutely no idea. I've not tried Create. I don't think it'll support third-party boards at this time. I really like the offline IDE editor. I don't even know if CodeBender supports ESP8266, but the ESP8266 it takes so long to compile and upload that honestly, using the desktop IDE, it works really, really, really well now. Like they've really nailed the Arduino add-on. Maybe I'll do another reset test. So this time I'll actually tie reset to ground, and I'll time it. So it's 11:52. Okay. Was that it? Was a good video? We got through some stuff.
Okay. So yeah, you can. And I mean, I can do some of these, but you can also do these. Can you give me a reason why to use Adafruit IO other than SSH keys and shell scripts, and what's the difference between like Dweet.io and Freeboard?
I actually don't know the difference between Dweet.io and Freeboard, although I think it's basically one does the MQTT broker. I think Dweet does is an MQTT broker, and then I think Freeboard is the interface. So Adafruit IO just has it all in one. we're abiding by the Internet of Things Bill of Rights that we had published in the New York Times.
I can tell you another one is like shell scripts.
Oh, and why don't you use shell scripts?
Shell scripts and like cobbling all these different things together is one way to do it, but we're an educational company and we want to teach people how to do things with the hardware that we make. And so all of the other sites out there, they don't make hardware, so it's very difficult to get this working. Like we can do a demo in 5 minutes.
Live demo, yeah.
And so that's the point, getting people up and running fast with the Internet of Things and not wasting their time remaking the same things over and over and over.
I mean, the thing about shell scripts, and I'll just be honest with you because I've written a lot of shell scripts, is doing things with just, if it's just you're connecting one thing in your home to another thing in your home, absolutely, you can do it. You'll have to just maintain the server and make sure it's updated and stuff. The minute you want to get to the outside, like for example, like we just did a demo here where I pulled a slider and LED lit up. Okay, obviously I could have just written all that code on an Arduino. Like why even have the slider? I just have a trim pot. But if you want to connect this to other services, like for example, If This Then That or Zapier or like your Amazon Echo or your Gmail account. There's APIs that allow you to tie these into Adafruit IO, and so you can shuttle messages around. So I'm just doing a basic demo here, but if you want to take a tweet and display it on an LCD, you can do that with shell scripts, but it's really trivial to do it with Adafruit IO because you just set up an If This Then That, you have it go to Adafruit IO, and then you have your ESP8266 or Arduino compatible connect to Adafruit IO, grab the string and display it. Like you don't have to worry about like SSL certificates and like OAuth and OAuth 2 and like all these details. Like it's all taken care of by these APIs that make it really, really easy. We've written Twitter printers and they were a real pain to do because every few months Twitter would change their API. And so we'd have to open up the Twitter printer and connect a serial cable and edit the Python code because they're now using a different version of OAuth. So like that's why Adafruit IO is nice, is that you don't have to worry about that part. You just connect using MQTT, a totally well-established like protocol that's very simple.
Okay, shout out to Jeff.
Hey Jeff.
And also, someone wanted to know the amount of data that they could store, and Justin answered 50,000 rows of data right in the open beta, and a rate limit of about 2 inserts per second.
Yeah, there is. As we've demoed, I'm only writing data every few seconds. We do have a rate limit because the server. I mean, we can't have millions of people all streaming live audio, basically, or video. Yeah. So there's a limit of how many rows, 50,000 per feed, I think. Of data, so I can send 50,000 photocell entries, and it'll just drop the oldest ones. That's a lot of data.
2 inserts per second.
2 inserts per second, which is quite a bit.
And we'll have a pro offering where people can pay money and have more once they start really using it. But we're just
so far it's actually most people are very happy with that. Two inserts per second is quite a bit, and that's per feed, or maybe it's per connection. I don't remember, but that's enough for like most sensing data. And if you're doing interactive stuff like moving a trim pot or a motor 2 times a second, it's not too bad. Like it's not. I mean, MQTT doesn't have a guaranteed response time anyways, so just be aware. Even though it's extremely fast, there's no like, oh, you must deliver by this time. Keep that in mind for real-time uses.
Yeah. Okay, that's it. You're out of here.
Okay, thank you everybody. Sign up for Adafruit IO and check out the MQTT tutorial if you want to read it, not just listen to it. And you can, you don't have to use ESP, you can use Arduino. We also have example code with, I think, Node.js and Python for a Raspberry Pi or Beagle and Black, so you don't even have to write code in C if you don't want to deal with parsing. It's very, very easy. There's also a desktop app which requires Java, which I'm installed, but you can also just do it from your desktop, writing and reading feeds. So MQTT is definitely like, at first I was like, I don't get it, why not just use REST? But like, as you can tell, it's really, really fast and lightweight and fun.
All right. Well, thank you, everyone. Thank you, everyone on Twitch and YouTube Live and on Periscope and on Meerkat.
And don't forget to say thanks to Tyler and Justin and Todd if you're in the Twitch
Yeah.
chat, because I didn't write any of that code
Yeah.
for the MQTT broker. I just wrote this like a little bit of client code, and like everything on the back end is them, and it's just amazing. The dashboards and the feeds and graphing and everything just works really, really, really well.
Yeah, and if everyone out there just buys some hardware once in a while, we can keep doing this. So visit Adafruit.com and buy some Internet of Things hardware, and that's what fuels.
Well, if you
all
pick
this.
up a Feather, it's like a perfect add-on.
Yeah, you get one of these right now.
And you can just make your own Internets of Things.
Not bad. 2016. Look, you got a dashboard in the back. You're
Bleep, 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 bleep.
on HD broadcast.
Doing things.
4 different networks.
Sliders.
It's pretty exciting.
Yeah.
No one else is doing this, Lady Ada.
Well, it's midnight.
Yeah. All right, that's it.
Hack the planet.
Okay. Probably see you guys tomorrow. Bye-bye.